Hi, and welcome to this video about this newly released MCP 2.0 version from the .NET. So the 2.0 version is the NuGet package. MCP spec by itself have a different name, which we will talk about a little later. But let's start by actually trying to upgrade and see how difficult it is. So here are my samples, and up in tools and MCPs, I have my MCP server here. It's a very simple server that just says remote server with tools from assembly, map them, and tools doesn't really matter here. It's just normal. So let's try and go here, and we can see there is a version 2.0. And major releases are normally an issue, of course. So let's upgrade and see how it goes. So we have now upgraded, and I will build the code, and let's see what we need to change. The build started. And I have a lot of projects, that's the reason why it takes so long. But once it's done, we will see we have absolutely no build errors. And if we were to use this and run it, it will work exactly the same. Because luckily, 2.0 is 100% backward compatible with a twist. So let's get into that. Up on the dev blogs of Microsoft, they have a really good article. You can see the link here that you should definitely go read in details if you want all the nitty-gritty details. But Jeff Hartland here goes through talking about version 2 being a major upgrade for this version. So these dates are the versions of the MCP spec. And he talked about the largest version ever. So before there was only new capabilities, now they have changed everything. And the changes is that the protocol is stateless by default. In the past, you had a persistent connection between the client and the server. And if that was gone, it was a problem, and it also gave some problems with various things like load balancers and so on that needed to be set up more advanced. But it is backward compatible and just switches to the stateless default instead. That means that in the past we wrote this code, and in the new we write exactly the same code, but this with HTTP transport is now, instead of stateful, it's stateless. You could actually do that in version 1.0 already, and I actually did a lot in most of my code. Going in and say options here and say stateless equals true, and then it already used it. But now it's part of the spec and the default. You can go in, and if you want it to be stateful still for some reason, you can go in and set this to false, and then it will work the same way. And the way this is set up is that if the client that you talk to understands the new stateless, it will use stateless, else it will fall back automatically. So all the old code behind the scenes is there, but it will take care of it running with the new version, because every connection you make, you always send this version in on what the client can handle, and then the server will react to that. One thing stateless gives is the ability to scale. And in the blog, they talk a lot about this being very close to how normal ASP works. So there's nothing special. And most of the things are being done, instead of this persistent connection, it's done with HTTP headers. So quite normal. And they also mentioned that the various different properties we could give to a system can also be sent up using this new MCP header up into the HTTP headers. That means that a proxy can just read the headers instead of needing to read the body. For example, if you wanted this region to send it to a specific server instead of just going to a random one. So cool if you need some scaling, and it's very much like what normal ASP.NET do now. So one thing, tools and resources are really good for this, but there's something called elicitations, sampling, and roots. It's rare. I must admit I have never either been a user or a creator of anything that uses elicitations, samples, and roots, mostly because many MCP clients didn't support it yet. More or less people do now, but now they can't really happen because elicitation was that the MCP asked the user for input. It could be you ask a tool and the server could ask back certain questions to the user that the LLM would then present to them. Sampling was that you could essentially get your MCP server to call the client's LLM to get some data back. It would essentially make a turn in an LLM. And roots was something about where it was allowed to work on the user's machine. Again, I have never ever used these, but of course, if you had these in the system, it would be a problem because of the spec. Because these required that the server could actually send messages the other way in that stateful session. So for that, something called multi-round trip requests are being introduced and will replace all of these. So it simply goes from server ask the user, server ask the client, server ask where to work. It's now just server ask something. And that's been put into one setup instead with some input required. So in their case, they show a sample where they have a support ticket that they want to close, and the server can evaluate if there's a close reason, and if not, it can ask for input required. That would be elicitations in this case. The client can then give that input, so they call the tool again with the input, and it could come back and be completed. Very much like tool calls actually happens in normal LLMs, where you also get this input required. The way it works is if we have a tool here that we asked to close a ticket, and you optionally could put in a close reason. So if the close reason wasn't there and it wasn't given by the input of the upcoming input response, it would, or if it was there in this case, we could go and see if they accepted it with the close reason, and we could get it. Else, they rejected to actually use the tool. So the tool was called. The tool said, "But before I can do anything, I need this." And the user said, "Cancel. No, I don't want to use it." Then we would end up here. But if a confirmed reason is being found, we can then close the ticket. If not, we need to check first if the setup we are running right now is supported with the multi-round trip requests. If not, we would need to just say to the LLM in English, please give this extra thing. This is what we would do before elicitations. But in the new system, you would actually throw an exception. So they have chosen exceptions to do this, so they can catch it in the inners of MCP SDK and send it out in the real format. So you give a dictionary with various input requests. So close recent input request, and you can use this input request for elicitation, where you can write what it is you need, what properties you need, and so on. So it's a more structured version of just this down here. This LLMs are actually pretty good at, but this will not cost LLM tokens, because this could be in a structured format by a client, just be shown to the user. Clients can, of course, also support this system, and it happens automatically. You just need to react to these handlers up here, and then everything will work. But most of you would not write clients. It's more normal that we write servers, and the clients being Codex, Claude Code, Copilot, and so on. The final thing I want to mention in this video is the packages. So we have, for a long time, had the Model Context Protocol and the core, and then we had the ASP for the HTTP, the remote servers. In those were also some experimental things like tasks and apps. Not something I've used, but tasks are long-running tools that the client can do polling on. They have because it's still a experimental feature. It's now been put out into an extensions namespace for Model Context Protocol, so it can live there by itself. And the same for the apps, which is the UI part, which I haven't done so far, but I have to do on making one session about that as well. But in the long term, and what we started with is just upgrade. It's probably very, very unlikely that you have any problems unless you have made some of the more advanced things for elicitations. The code will still work if you go in and use your normal elicitations and then set the options that serverless stateless equals false, then it will work exactly the same as 1.41. But that's everything. See you in the next one.